Okay, guys, welcome back to your final day before April break, which is kind of exciting. So today we're going to look at special systems of linear equations, which is a little bit different than everything we've done before. So what did we do before? We first solved them by graphing. So we took the two equations, put them on a graph, and found where the point of intersection was. The next one we did was we solved them by substitution, which a lot of you guys like to do. And then what we did last time, the last two times, was solve it by elimination. Now, I was noticing in some of your homeworks that you were solving the ones last time by substitution. You don't want to do that. There's certain times where you want to do substitution. There's certain times where you want to do elimination. Sometimes elimination is easier in certain times. Sometimes substitution is easier in certain times. Okay. But are these the only three ways? Well, no, because what was special about each one of these is they each had exactly one solution. So if we were to graph all of them, it would have exactly one point of intersection. Okay. So today what we're going to do is we're going to look at ones that don't have one point of intersection. Okay. Or just one point of intersection. So this is what we've done before. So lines that intersect have different slopes. Now, if you remember from last chapter, we talked about parallel lines, and what's different about parallel lines is they travel in the same direction forever and they never meet. Well, in order for them to do that, they need to have the same slope, but they need to have different y-intercepts. And third one is if they have infinitely many solutions. And basically the way that works is they're the same line. So they have the exact same slope and they have the same y-intercept. Now, the way that the equation is written, sometimes it's not always that easy to say. So this first one, we can solve it two different ways. Okay, we can solve it by graphing. So y equals 3x plus 1 is this one, and then y equals 3x minus 3 is this one. Now you can see that they're parallel lines, they never meet, so there's not going to be a solution to this equation. So it would be no solution. That just means that there is no value for x and y that will make both equations true at the same time. Now looking at this, you can tell that they're in slope-intercept form. So y equals mx plus b. So y is here, the slope is the same. So as soon as you see the slope is the same, you know they're automatically parallel. If they're parallel, they do not have a solution, or there is no points that are going to be the same in either of the lines. Okay. Now, if you come down here, now this equation, these two equations are just these two equations. All we did was just subtract 3x from both sides, and we just moved it over here. So if you notice, if we use the system of linear equations, we would subtract the two of these, and 3x minus 3x is 0. Y minus y is 0. Well, last time I checked, 0 cannot equal positive 4. I don't know where that works, but not here. The other way you could look at it is, how can you have the exact same equation be equal to two totally different numbers? That's not possible. Okay, so since 0 cannot equal 4, or the same equations can't equal different numbers, that's how you know there's no solution or no value for x and y that are true in both equations. Okay? So looking at this one, okay, obviously you would solve this one by graphing, or even in this case, just looking at it's a slope-intercept form. So the slopes here are both the same. The y-intercepts are different. So these are two parallel lines. Parallel lines have no solution. Looking at something like this, obviously we were going to use substitution, okay, because it tells us what x is. So let's come here and solve this one. So we're just going to substitute in x for here. We're going to put 2y plus 10 in here. So this is 2 times 2y plus 10. Oops, I write 10. Plus 3y equals negative 1. So 2 times 2y is 4y. Plus 2 times 10 is 20. Plus 3y, oops, I forgot the negative here, equals negative 1. So 7y plus 20 equals negative 1. Subtract 20 from both sides. 7y equals negative 21. Divide by 7. Y equals negative 3. So now let me plug this one into, just plug it into that equation because it makes it easier. because it'll tell us what x is. X is -3 times 2 plus 10. So x is equal to -6 plus 10. So x equals 4. So this one actually has an equation, or has a solution. Okay. So as you're solving it, if it comes out to be something that's not possible, such as one number equals a completely different number, we know it doesn't work. If we get to an actual point, we know that there's exactly one solution to that system. Okay, so now let's come here. Now, what happens if there's an infinitely many solutions to the equation? Okay. Now, what does that look like? What does that mean? All right, so we'll first solve this by graphing. So if I were to graph this one, it would look just like that. And if I were to graph that one, it would look just like that. It's the same thing. So even though this looks different, okay, it's actually the same thing. So if we were to plug this into Desmos, that was the last one we just did. Okay, so let's just plug it in. X plus 2y equals 6. X plus 2y equals 6. Okay, let's put the other one in. 3x plus 6y equals x 18. 3x plus 6y equals 18. Notice we get exactly the same line. Okay, we have an infinite number of solutions to this equation. Right, because it's the exact same line. So that means that, let's do this one here. 0, 3. 0, 3 is true here. If I put in 0 and 3, I get 6. If I put in 0 and 3 here, I get 18. Okay, so 0, 3 is a solution to this equation. But so is 4, 1. If I put in 4, 4 plus 2 times 1 is 6. 4 times 3 is 12, plus 6 times 1 is 6. 12 plus 6 is 18. That's also a solution to this equation. So every point on here is a solution to the equation. 2, 2. 2 plus 2 times 2, so 2 plus 4 is 6. 3 times 2 is 6, plus 6 times 2 is 12. 6 plus 12 again is 18. So every point on both these lines, because they are the same line, are solutions. So that's called infinitely many. So how does that look if you don't graph it? Okay, so let's say we solve this one by elimination. So in order to get the coefficients to be the same, we're going to multiply by 3. That'll get both x's to be the same. And it'll look like this. So we have 3x plus 6y equals 18, and 3x plus 6y equals, wow, they're the same exact equation. So when we subtract the two of them, 3x minus 3x is 0. 6y minus 6y is 0. 18 minus 18 is 0. Do you see how we got something that is true? A number equals a number. Okay, a number equals the same number. Because this is a true equation, that means there's infinitely many solutions for us to find. So let's come here. X plus y equals 3. X equals y minus 3. All right. So let's solve this one by substitution. We'll just substitute in y minus 3 for x. So y minus 3 plus y equals 3. Okay, so 2y minus 3 equals, 3. Add 3 to both sides. 2y equals 6 divided by 2. Y equals 3. Plug 3 in here. X is going to be 3 minus 3, or 0. Okay? So 0, 3 would be a solution to this equation. So this would have one solution. Now let's come to this one. Ooh, okay. Many of you want to jump in and automatically do substitution. We don't need to do substitution here. Okay? We're going to solve this one by elimination. We just want to get a coefficient to be the same. So if we multiply the top equation by 2, we'll get both x's to be 4x. So the top will be 4x plus 2y equals 5. bottom, I'll just rewrite it so we can eliminate nicely, equals 0. So now so we need to subtract this. So 4x minus 4x is 0. 2y minus 2y is 0. So all I'm left with on this side is 0. 5 minus 0 is 5. Is that possible? Can I get 0 equal to 5? No. So this means there is no solution. Okay. Now let's come to this one. Okay. Again, don't really want to do this one by substitution. Let's just do elimination. It's a lot easier. Let's multiply this to get a common coefficient. We multiply this by 6. Okay, because we'll get these both to be 12. Let's come up with that. So that's going to be 12x minus 24y equals 60. Okay. Now let's come here. That stays the same. Plus 24y equals negative 60. So how are we going to solve this? Well, if I have a 12x and a negative 12x, the way I get that to be 0, to eliminate that, is I'm going to add these two equations. So 12x plus negative 12x is 0. Negative 24y plus 24y is 0. So on this side, I'm left with 0. Over here, I have 60 plus negative 60 is 0. So this is true. So since 0 equals 0, this is what's called infinitely many solutions. Okay. So once you find an x value and a y value that work for this equation, that same exact x and y value will work here, and whatever x and y you figure out here, they will work here. Okay. So let's just go over that real quick. One solution means you come to one point when you're solving it. Okay, there's one true solution. If you are solving it using substitution or elimination, there'll be no solution if you get to something that does not work. It doesn't equal one another. Okay, you get something like 0 equals 7 or whatever. Okay, something that's not true. Or if you graph it, okay, you just find, you just see their parallel lines. So such as, let me just put it there. So for example, this one, okay, y equals mx plus b, you can see their parallel lines, therefore they are, there is no solution to that equation. And last but not least is infinitely many. Infinitely many is where they're the exact same line. So if you're solving it by substitution or elimination, well, usually it's elimination is the way you can figure it out. You get 0 equals 0. Okay, so your assignment is in big ideas, right? Have a good break. Try to, once your assignment's finished, have a good break, and we'll chat again after break.